Welcome to The Explainer. Today, we're basically going to put on our digital forensics gloves and do a full code-based autopsy on a really fascinating tool for developers, OpenAI's Codex CLI. So, have you ever wondered how a modern terminal-based AI agent actually gets built, under the hood? Well, if you're a developer who's into local-first AI, you're in for a treat. We're going to answer that exact question by dissecting the architecture of the Codex CLI, and we'll be using its own public GitHub repo as our guide. All right, so here's the plan. We're going to treat this just like a real autopsy, starting from the outside and working our way in. We'll look at what the tool is, how you actually use it, then we'll dig into its guts, the core language, its modular skills system, the heavy-duty tools used to build it, and finally, wrap it all up with why this stuff even matters for the future of local-first AI. Okay, so first things first. To start this examination, let's just look at the surface. What does the project's own documentation say it is? What are we even dissecting here? Okay, so the official definition says it's a lightweight coding agent that runs locally in your terminal. And honestly, those are the magic words right there, lightweight and runs locally. This isn't some cloud service you're hitting with an API call. No, this thing is designed to live and breathe right where we developers do our work, the command line. All right, so how do you even get started with this thing? Well, it turns out the installation process itself is our very first big clue about the whole design philosophy behind it.
And just look at this. There's no wrestling with complex dependency chains, no NPM install that pulls down half the internet, no configuring environments. You just download a single file, you extract it, and you run it. That's it. This screams portability. The goal was clearly to have a minimal, almost zero footprint on your machine.
And this is what it all boils down to. All of that complex engineering, all those design meetings, it all leads to a single, simple command: Codex. That elegant user experience is a dead giveaway that some really smart, very deliberate choices were made under the hood. So that brings up the big question, right? What is this simple little binary actually made of? Well, a quick peek at the repository's language stats gives us a really clear answer. Whoa. Okay, so what's absolutely striking here isn't just that it uses Rust, but the sheer dominance of it. 96%. That's not an accident, that's a statement. Choosing one language for pretty much the entire project is a fundamental architectural decision. It dictates everything: performance, security, how you ship it, the works. And it makes perfect sense, right? This choice of Rust is what makes all the stuff we just saw possible. You get that raw, native speed you need for a responsive AI agent, so it doesn't feel laggy. You get memory safety built in, which is absolutely critical when you're talking about a tool that might generate or even execute code on your machine. And, of course, Rust is a champ at compiling down to those single self-contained binaries we saw in the install step. It all connects. Okay, let's keep digging. We're moving deeper into the codebase now to look at the file structure. This is going to show us how the tool isn't just fast, but it's also built to grow. How are its capabilities actually organized? So as you're poking around the repository, this one directory just jumps right out at you: skills. For any developer, a name like that is a huge signal. It pretty much tells you that the agent's functions aren't one giant, tangled mess of code. Instead, they're broken down into these nice, discrete, manageable chunks. And you don't even have to guess. A recent commit message flat out confirms it. You can see the team is actively splitting instructions into individual fragments right inside that skills directory. I mean, that's the classic hallmark of a plugin architecture. It's designed from day one for easy extension and maintenance. All right, so we've got a fast core and these modular skills. That's great. But how on earth do you manage the complexity of building and testing all this stuff, especially when you have to support multiple platforms? Well, the files in the repository tell that story too. Yeah, this is not your hobby project's simple make command. This project uses a sophisticated, professional-grade stack of tools. You've got Bazel, which is built for massive, complex monorepos with multiple languages. You have PNPM to manage the JavaScript parts efficiently within that monorepo. Then there's Nix, which is awesome. It ensures every single developer has a perfectly reproducible environment, to kill those works on my machine bugs. And finally, Just gives them a simple command runner to tie it all together. This is the industrial strength scaffolding you need to build a serious cross-platform product at scale. Okay, let's take a breath. We've gone all the way from the simple install command down to the Rust core, into the skills folder, and through the build system. So, What does this all add up to? What are the big takeaways from our little autopsy here? What we've really uncovered here is a blueprint for a top-tier modern developer tool. It's laser-focused on a fast, local experience thanks to Rust. It's security conscious right down to its bones. It's built from the ground up to be extended with new skills, and it's all wrapped up in this neat little package that's just ridiculously easy to distribute and run. When you really think about it, this deep dive into the Codex CLI does a lot more than just explain one tool. It gives us a really clear architectural pattern for building that next generation of developer agents. They need to be performant, secure, extensible, and live right there in the terminal with us. For anyone building in this space, this is basically a roadmap for the future.